sure that you've looked in and it's there. I'll give you all the details. We're going to continue and finish today, that's my goal, the hypothesis testing of a single proportion. And the questions we're essentially going to do is starting at question 7 onwards, right? And we're really putting all the pieces together now. So I'm trying to get this one so it doesn't have the answers, because it just is a distraction.
Did we have class on Monday?
No, Monday was a holiday.
Okay, so we already went through all the 25 questions on the hypothesis testing part A.
Part A, most of that is just read it in the textbook and do it. There's not too much, and we have covered some of it as well. The main number crunching stuff is what we're doing now, right? Which is the main part, right? How do you do a hypothesis test? So here is our first one. About 10% of the human population is left-handed. And suppose a researcher speculates that artists are more likely to be left-handed than other people in the general population. So he collects 200 artists and he finds out that 26 of them are left-handed. If we use P to represent the proportion of all artists who are left-handed, then the hypothesis test is going to be, the null hypothesis is that the percentage is 10%, and the alternate for artists is that it's more. And they give us basically, they repeat the information that they had up here. So we're going to go through essentially the hypothesis test process. Now, we're given information. Do we know if the conditions are necessary? And I know they say to use a Z statistic. I wish they would just say to use a hypothesis test. So we are sure that the sample was selected randomly, right? Isn't that one of your conditions? It has to be a good, fair representation. And that the sample size is large enough. And it's large enough because, remember the 10 rule, right? NP, N1 minus P are greater than 10. NP and N1 minus P, you could take that into English as at least 10 people said yes, and at least 10 people said no. Now, if we look at this survey, 26 of them said, yes, I'm left-handed. Now, out of 200, doesn't that mean there's well over 100 that said no? So we know it's okay. If this had been, we asked 15 people and 5 of them were left-handed, that wouldn't pass the test, right? Because 5 is, 5, NP is 5, is just not big enough, right? It has to be at least 10. Now, it then goes on and says, state the population of interest. Now, it's easy to think that we're talking about the entire human population, but later on, that there tells me that we are only interested in a subgroup of them, right? People who are artists. So the population of interest here are artists. And the population parameter is the proportion of artists who are left-handed. And the sample statistic is 0.13. Okay. Now, conduct a hypothesis test with this significance level, right? So we're going to be using SALT in a minute, but let's get this bit over with. The null hypothesis is always going to be equal to something, in this case, 10%. And we think that left-handed people are better than that, right? So that's greater than. Now I'm going to have to write down some numbers here. It's what, 26 out of 200. That should be all I need. And I'm going to hit use the SALT button. And I'll bring it over here. And, oh, it's on inferential, that's good. Can you remember which one of this list do we pick for the
One
questions that
sample
we're,
proportion.
yep, every single one of them, right, for this section. Now, we know that the number of successes in this case means left-handed people. So it's 26 out of 200. And we know the null hypothesis was 0.1. And we're trying to prove that it was bigger, right? Greater than 0.1. And we are on hypothesis test, yep. So when we generate results, this is pretty much everything we need. In fact, these two numbers are more important. And out of all of them, this is the most important, right? Because that number there is going to tell us whether or not we have evidence to prove that left-handed people, artists are more likely to be left-handed. So I'm moving them out of the way, but here we go. Compute the test statistic. That guy, I'm copying it, was that number there. And they want it to 2 decimal places, so there's your answer. They have a p-value. So the p-value can be thought of as the percentage, or in this case, the proportion of time that they want 4, don't they? So I guess I'll make that 7. 7. Basically, the p-value says, what's the probability that you would get the results that you got and there was nothing going on, right? It was still 10%. That is very unlikely, right? But is it unlikely enough? Well, on the basis of the p-value, make a conclusion. We do not reject the null hypothesis. And that is because our p-value is greater than 0.5. Right, you remember this guy up here, 0.5? Wasn't the test, is the p-value less than? Right, is the p-value less than that? No. So you don't reject the null. Why? Because it's not less than, it's bigger than. And we cannot then conclude that artists are more likely to be left-handed. Now that sentence, do not reject the null hypothesis, just means there's not enough evidence. The alternate situation would be to say you reject it. But if you write that down, that means we can conclude that there is evidence, right? So rejecting the null means you've got evidence. Do not rejecting the null means there isn't evidence. So that's just another phrase you got to kind of put together. So do not reject the null happens when the p-value is too big. Reject the null hypothesis is when the p-value is nice and small. And in this case, what does small look like? You have to be less than 0.05 to be small. Right, well, that's pretty much an entire hypothesis test from start to finish. So let's do another one. A certain magazine reporter reported that in a survey of 550 randomly selected adult Americans, 58% answered yes to the question, do you favor allowing women to be priests? So they basically told me that p hat is 0.58, at least that sample does. Okay. Now, set up a null and alternate for deciding whether more than half. So the null is it's exactly half, and the alternate is more than half. You comfortable with that choice? The null is always equal to something. In this case, they told me in English, a half, but that's 0.5. Now they have a whole list of conditions here, and we talked about this yesterday. Don't you have to have things like the sample is random, right? It's fair representation of the population. Doesn't the sample have to be big enough? And don't we have to do that in what's called the 10 test, right? The NP, N1 minus P. So, yep, that has to be true. That has to be true. That has to be true. And those three would be really silly. I can never think of a reason in the universe why your sample could be too big. I mean, is it not like being too good looking or too intelligent or too rich? With very few exceptions, I don't think you can be two of any of those things. Are these conditions met? Yes. Well, I should check them. If you do that guy is 0.5 and the sample is 550, then that guy times 550 is 200 and more. And that guy times the other number, which also works, is more than 150. And is it big? Yeah. So yeah, they are met. Now, all these guys here are going to come from salt. And do you remember what we had to do to make salt work? Because sometimes the numbers they gave you aren't any good. They told us p hat was 0.58, and they told us that the sample size was 500. But don't I need a something out of 550, right?
I just turned the percentage into a decimal and times the sample size.
That's exactly what you should have done. And this time you get 319. And let's just keep our fingers crossed that it's always a whole number. Because remember the 16.5 problem we had last time where WebAssign says, but that's the number we got when we did the multiplication, right? At least I believe it was. So I'm now ready to put all this together and find the test statistic, which is the z-score, and the p-value. So hit this guy, move him over here. Inferential is good. One sample is where we should be. Take this fella, and it ends up being 319 people out of 550. We have a hypothesis test, and I should have looked. What is the hypothesis? 0.5. Okay, so that's good. And we want to prove that it's bigger. So generate results. Here is your Z statistic, and here is your p-value. So I'll copy this guy over. Z guy goes there to 2 decimal places. And wow, this is cool. Look at the p-value. Now 1, 2, 3, 4. If you round that off to 4 decimal places, you end up with a 1 there. Now, somewhere up here, they should have mentioned the significance level. So we're going to have to make an assumption, which I'm pretty sure is true, that if they don't mention it, the significance level is 0.05, right? The alpha is 0.05. Right. Now, is that number there, my p-value, less than 0.05? Agreed? Yes? Now, when it's a yes, we can reject the null hypothesis because our p-value is smaller than 0.5. Do you see how you phrase that in English, right? When it's right, when it's less, you reject the null hypothesis. And that is cool. And then they done this, the little players. I wasn't predicting this. Don't they also want a 95% confidence interval, which is really nothing to do with this, but we are going to do a 95% confidence interval. So I'm going to have to go back here. Where will I get the confidence interval from? Well, don't I just click on that button? You see the one there, confidence interval. And then I should just be able to hit generate results. And these are the 2 numbers that they want. So I'll go over here. And the lower limit on the thing was that guy. and the upper limit was that guy. And to 3 decimal places, that's 539. And to 3 decimal places, that's 621. And would you agree that this interval backs up what we have here? Right? It's bigger than 50%. So this confirms it. I wish they had put a sentence like this at the bottom. When you say you reject the null hypothesis, couldn't you say then we have evidence that proves the majority of Americans are in favor of priests being women in this question? Any questions about that? Are we getting the flow for how this process from start to finish is going to work? So this is not really much of a question, so I'm just going to tell you what it is. If you do a one-sided test, that means prove it's bigger than or prove that it's less than, and you get a p-value when you try it and it ends up being 0.03. It says, what would the p-value be if you did everything the same, but you did a not equal to, which is what a two-sided test is. What do you think the p-value? You got it. That's all it is. So now that I've told you that, that's what all of them are, right? It's going to be double the number. Right, moving on to 10 then. A poll was released in the year 2000, and it found out that 48% of 2000, you better start writing this down, 48%, so that's p hat is 0.48, of 2,100 randomly selected American adults classified themselves as very happy, and it tells you the choices. Suppose a journalist is a pessimist, took advantage of this poll to write the headline, "Poll finds that significantly fewer than half of American adults said they were happy." Now, I know it said 48%, and we know that that's obviously less than 50%, right? But he used the word significantly fewer than a half. Couldn't you have got 48% from a sample just by randomness? Couldn't the real answer be 51% were happy, but you just happen to be unlucky and get a few more pessimists, right? So we have to go through the statistics of this. So if P is the proportion of American adults that are happy in the year 2000, we're going to go through, they call them the 5 steps to test if this is true. And thank you for telling me the significance level. The null hypothesis is going to be P equals 0.5. Because if you talk about the majority, doesn't that mean bigger than 50%? So if the question is about politicians winning an election, it's 0.5, right? If they talk about the word majority of people, well, the majority is bigger than 50%. Now we want to show, or he's at least trying to prove, that less than half of Americans. So that's the one we're doing. Now let's go through the various tests. Participants in this survey were randomly selected. Agreed. In addition, NP0 and N1 minus P0. Basically, if you take that sample and you multiply it by this fella here, you will get 1,050, right? So that's 1,050. And 1 minus P0, right? 1 take away that number is also half, so you get another 1,050. Both quantities are at least 10, which they certainly are. So we have found that this condition are met. And then it says calculate the test statistic. What's that going to be called when we do so? What do they call the test statistic? What's the other name for it? The one that you'll see when you do it. Any recollection? What's another name for what they call the test?
T-score.
In this case, Z-score. T-score would actually be true when we do means, but when you do populations, it's proportions, it's almost always Z, right? And when you do means, it's always T, but you're pretty close. So that's going to be the Z-score, and that's obviously the p-value. So it's time to bring salt into play. Have I got all the numbers I need? Yes, I do. Okay, so. Oh, I don't. It's 48%. Okay, so off screen, I'm going to do this calculation. One proportion. We have 2,100 people in our sample. And over here, we've got 2,100 and 48% of them were happy, which is 1,008. And we're doing a hypothesis test. And it's 0.5, and we're trying to see, is there evidence that it's less than, right? And now generate the results. Here is the Z statistic. And here is the p-value. So I've got a Z statistic, which is going to go here. And I have a p-value, which is going to go here. It's a nice low p-value. We'll see if it's low enough in a minute. To 2 decimal places, that guy just becomes him. To 4 decimal places, 1, 2, 3, 4, that becomes that.
Where'd you get 1,050 from?
I got that, this number here, by
Yeah.
multiplying that number by the 2,100 people that were in the sample. So that's NP, right? Or NP not as they're calling it. And N1 minus P would be N 2,100 times 1 takeaway 0.5, which also happens to be 0.5. So that's why they end up being the same.
How do you get the number of success?
I found 48% of 2,100. So that would be, turn it into a decimal, 0.48 times 2,100. And when you did that, that gave me the 1,008, the number of successes. Are we good? Right. Now, the p-value is less than the significance level of 0.05. Would you agree this guy is less than that? So there is sufficient evidence to conclude that the headline is justified. Well, let's say at least true in a way. But I have problems with the way they phrased it. This guy went and said significantly fewer than a half. Is 48% significantly less than 50? You know, because the English language is different from statistics, right? When we say significant, we just mean what we've just done here. Yes, it's true. But I would argue that that phrasing, statistically significant, is different from practical importance. I don't know if I'd phrase it that way. Wouldn't it be a better way to say there's evidence that less than half Americans are happy? The minute you say significantly less, to me anyway, doesn't that sound like it's a lot less? Like, you know, 20% of people are happy, you know, that kind of less. So there's lots of answers. You put your answer in there. Analogy. Let's go show you something. Pretend for a minute that there's a new drug out there. And this one helps your blood pressure, right? And the old drug is 91.0003 3% effective. In other words, for 91.0003% of the people, it does what it's meant to do, right? It reduces the blood pressure. And there's a new drug, and it ends up being effective, and it ends up being 0.004%. And this drug costs you $1 a pill, and this drug costs you $1,000 a pill. Do you think it's worthwhile even introducing this drug into society? Statistically, we've managed to prove that it's better. But isn't the better not that much better? And so you could argue that this new drug is not bringing anything worthwhile to the market. It's a lot more expensive for very little extra benefit. And that would be one argument that you could give. Aren't a lot of generic drugs almost as good as the brand new, very expensive drugs, right? A lot of them are, at least. So when you go to the doctor and you get a prescription, have you ever had this situation where he gives you a prescription, then you go to the pharmacy and you find out it's like an arm and a leg, and which child do I need to sell just to buy the damn thing? And you go back and you say to the doctor that it's too expensive, because sometimes they don't know. Oh, I didn't realize that. Well, here's a generic version of that. They'll do pretty much as good, right? And that's just the kind of thing that's going on. Now, not a lot of drugs are extortionately expensive, but if you're on a tight budget, right, sometimes it's cheaper to do that. Useless piece of information, but it's in my head, so I want it out of here. Do you know in Britain we have what's called the National Health Service, and if you go to the doctor and you have you think you've got a major illness, but let's say you don't, and the doctor says you just need ibuprofen. They write you a prescription, right, for ibuprofen. If you go to the chemist, you know ibuprofen, if it's a doctor's prescription, costs you more money than if you just say, I want a box of ibuprofen. Now you tell me, where in the world does that make sense? That a prescription costs you more money than if you just bought it over the counter. Now you can't do that with every drug, obviously, but that just shows you an example of what's happened. So very often your doctor will just say to you, there's no point in me writing this prescription, just buy your own ibuprofen, save some money. But if I don't know, if somebody else is paying for it, you can actually do it, because some people, their finances are quite low and their prescriptions are paid for them. Of course, I'm not sure whether that's what you should do, but hey, back to our stories. We are on schedule. Good. I thought we'd get finished today. In the previous example, what previous example? Oh, good. I didn't do the previous example, so there's only be one version of this question. In a previous example, results were given for a survey of students in a stats class where they measured the length of their right and left feet. God, people have too much time on their hands. To the nearest millimetre. And suppose that the right and left foot measurements were equal for 106. Oh, there's the numbers that we want. 106 out of 220 students. And assume that this is a fair representation of all college students. Is there convincing statistical evidence that the proportion of college students whose feet are the same length differs, there's the word, differs from a half? Okay, and let's go through the steps. Well, P equals a half. Now, when they say differ, what do you think they're saying? Greater than, less than, or not equal to? I can't even blame Zoe because she wasn't anywhere near. So it is what it is. Now, if I recollect, which is not good, we were talking about the stories to, where was that story? 106 out of 220 people. That much I've got here. What was the story about while I'm loading this up?
It was the feet in number 11.
Oh, it's feet being the same and feet being not the same. While I was gone, did some of you measure your feet just to see if you were abnormal or whether it was normal? Not one of you bothered to get out a measure and do your feet. Okay. I'm slowly loading up all the bits and pieces that I need to load up that also crashed because I had to reset my computer. And that is this little darling. Just in case. No, she's not underneath the table. I'll be back on that question shortly. 2 more buttons to press and then I'll be in. In view. Okay. So I'll switch over. It's our last question, so I'm kind of happy that we had a few extra minutes to spare anyway. And I won't need to worry about rushing things. Right. So here is the story. Of course, it's now changed to 107 people, but everything else is the same. And I'm not going to do that not equals to button in case for some reason that crashes the world. But it's that fella, and then we'll do their not equal to 0.5. Are you comfortable about the null and alternate? Right, now, let's check that all the conditions are met. We are told that we can assume that it's a representative sample. In addition, we found NP naught. Okay, if the sample size is 220 students, NP naught is going to be 220 times that guy, which is what, 110. And then 1 minus P naught is also going to be 1. If that had been 0.3, then it'd be a 0.3 and a 0.7. But they're both the same number, so you're both going to be 110. Both quantities are at least 10, so we have that all the conditions have been met. And then T and P is coming up, so time to hit the button. And one sample proportion, where we will do 107 people out of 220. And that's that one. Oh, and it's already got a not equals. And I'll generate the results. And here is our Z, and here is our P. So, see. There we go. Okay, are you looking at question 11? Is that what you can see? Right, so the test statistic, which is another name for the Z guy, goes here into 2 decimal places. It looks like that. And the more important value is the P value. Which is that guy into 4 decimal places. You get that. This is a no-brainer. Isn't that P value huge? Right, it's 0.6 and stuff. That's never going to be less than 0.05. There it is. Somewhere in there, there's a 0.05. If they're not, we assume that it is that number. So the P value is greater than the standard significance, which I'm assuming is 0.05. So there is not sufficient evidence to conclude that the proportion of college students whose feet are the same length differs from a half. And we're finished.
Since we have a little time, can I actually ask you a question about a past test? Or
Okay,
should I
I'll
wait till
try.
tomorrow morning?
It is only like 2 minutes to go, so it probably would be a bit, it would be helpful if you could do that. Okay, or catch me during office hour, which is even better. I know there's people around, but sometimes there's nobody around, so sometimes you can be seen quick and other times you have to wait a while. Okay, that is it, last name and bye-bye. Tomorrow we do the last part of chapter 2, which is hypothesis test for the difference between two proportions. It's not that different. It's very similar to what we've done, just an extra bit. But everything else, pretty much same old, same old. So hopefully we'll get through that one. We will tomorrow. And that's chapter 10 done.